Thank you very much. Welcome everyone to the second part of my uh, talk. Last week, I spoke and I touched on design as an important aspect of our work and that we must always strive for good designs. However, it's also very important that designers know and understand building construction and structures. That was a key theme of my talk last week. If you combine construction and structures, then you are able to come out with your dream design. And that's very, very important. I also gave you an example that if I ask you to design a cube, and the cube is 25 mm by 25 mm, no issue. You can do it with your eyes closed. But if that cube becomes 25 meters by 25 meters by 25 meters, it becomes a different issue that may be beyond your design depth. Sorry, there's a thunder lightning storm going on out here in Kuala Lumpur at the moment. I hope it doesn't impede you from hearing me. Okay, so that's the point. We must know how to put things together. So that was last week's lecture. Now, today, part 2, I'd like to walk you through how we made the Salinger's house back in 1993 to be energy efficient and environmentally friendly. Energy efficient and environmentally friendly were not the norm back in the 1990s. In fact, it was the precursor to green architecture. And green architecture was at that time not trendy or in vogue. Now, this is important because the jury in selecting the Salinger's house commented that it was an example of excellent architecture, which is contemporary yet not alienated from its specific cultural context. So, in other words, whatever that we design has to be relevant, contemporary, but yet specifically related to our cultural context. And that is something we must not lose sight of. In today's world, too many of our designers are Googling ideas. And ideas that you get from the internet are not worth anything. That's my opinion. Okay? Then the other thing which the juries commented was the high technology and energy depleting services need not play an issue if we are able to be creative and employ vernacular architecture to create something that's suitable for our contemporary lifestyle. So we take these two comments by the jury to be very, very important. So, but prior to that, we had a vision. We had the client's view. We were told what they wanted. This I very explained last week. But then, the other most important thing which we tried to do to design a building that provides comfort. Comfort using good design ideas to achieve energy efficiency, and environmental friendly values. As I said, green architecture that is ecologically sustainable and renewable energy resources were not heard of in those days, in the early 90s. It was not fashionable. No one has coined out those words yet. Now, the Salinger's house, in hindsight, was ahead of its time. It was before green architecture was thought of. There was no GBI, there was no LEED, no green mark, no green index. We were simply doing sensible and comfortable building designs for the tropics. Why for the tropics? Because we are from the tropics. We have to be relevant to our environment, to our climate. We don't design something that we extricate from the West, totally alien, and put it in the tropics. I was saying at that time, the Salinger's house was ahead of its time. Green architecture was not thought of yet. It was still coming. Now, I was saying that at that point in time, all we wanted to do was to design comfortable, sensible buildings that was suitable for our climate. And it's very important to know our climate, our environment, our weather. In Malaysia, in the tropics, we have two seasons. One is hot and wet. The other is hot, wet, and more wet. These are the two seasons. So we just have to keep ourselves dry and cool. That's it. So, as I was saying, we were ahead of the green building index and that sort of thing. What it baffles me, this green building index GBI, you have to use all sorts of expensive M&E equipment before you get points. And it's only when you've got all these points that they give you a gold award or platinum award and all that. It's rubbish. Let's not be conned. GBI, as far as I'm concerned, is another way of imperial recolonization. Okay, thank you. Now, when we talk about energy efficiency and environmental friendly, what are we talking about? We are talking about looking at a lot of things. The site is the first thing that you have to look at. And what do you do when you go to the site? You've got to look at the vegetation. You've got to look at the land formation. You look at the lay of the site. You look at the fall. Look at the surface drainage. Telltale signs of where water falls, a flow. When after a big rain, you look at the rock formation, positions of large prominent trees, distinctive flora, visual elements, views, hills, rivers, any land failures, landslides, or excavation. These are the sort of things you've got to look at. And once you have identified the land, you then select the best location to site your house. And from that position, you've got to understand the orientation, where the north is, where the views are, prevailing winds are. Now, these are the sort of elements that you need to look at in order to create energy efficient design. Here is a picture of the Salinger's house at the site. You see all the trees around are still there. when we started construction. We only removed what had to be. The land was not level. We just built on the land. We kept the terrain because the way the land falls was the way nature has made it. So the way it flows, water disperse. That's very important. That's why if you do not touch the land, you'll never get any flooding. But a lot of engineers and architects, first thing they do, cut the hill, fill in the valley. Once you do that, you stuff your whole environment. And you're going to give yourself a lot of trouble, and your project costs would go up. Totally non-sustainable. Now, this is another site on the hill. You look at all these little rocks that we have here. We kept them, we left them. They form part of the conversation of the hill slope. The trees are all there. These are old rubber trees, not unlike the Salinger's house. And the house is sited in such a way it catches the prevailing winds. These are the sort of important things. Then we look at other things that contribute to environmental friendliness. The selection of the material you're going to use for your building. The placement of your building on site. The orientation, the aspects. What are the trees you want to preserve? What are the trees you need to remove? And most important, what type of construction technique you're going to use to minimize the environmental impact on nature. Many designers, many architects, many engineers are totally oblivious and insensitive to the environment. You know, you've got to look after the environment, and the environment will look after you. Remember that. So we use timber. We get the sizes of the timber that are closest to the sizes that we need. And there's no wastage. Now, this is a site plan of a project that we did recently. This is a site. It's quite a large site. The road is up there, and the land slopes away to a river. So, and the view is in this direction, in the easterly direction, right? North is facing up there. Now, this is the highest point, and we located the house here because it gives you the best view and so forth. And on this side, there's only one tree left, and this was a tree, and we had to keep that. We kept that so that it became an integral part of the way the building was laid out. And here you can see the tree. See, the tree is here, and that's where the house is sitting on the high land, and the land is falling away, right down to the bottom, where we had created a pond so that it can catch all the rainwater, surface water that will fall off, and it provides something pretty. Not unlike what we did at the Salinger's house. Then the other thing about doing a sustainable building is you must know how to have sustainable detailing. The detailing is how you put the building together, all right? And you must know what are the methods. In this case, we use timber. And timber as a building material is talking about sustainable detailing. So in timber construction, you must know a lot of things, how to connect timber and what have you. And in that way, you can control the type of building that you produce. I have listed down a few examples just to show you. I'm not going to explain anything to it take too long, but just for you to have an impression of what's involved when you talk about timber construction. Okay, here you talk, this is a dovetail junction. They got many variations. Mortise, tenon, and lock, right? Tongue and groove, right? Simple, straightforward. Bird's mouth joint for the rafters and for the ridge of the roof so that the roof would not get blown away. Doweling. At the base of every column, every vertical component of a building, you must have a dowel. The dowel is to stop the thing from moving. Housing is when you describe putting a piece of wood into another piece to provide stability, and that's very important so that your building do not become wonky. Lapping. Sometimes timber is a bit short and you need to extend it a little bit, so you need to lap. In overlapping, you got to ensure the continuity of its strength. Then you talk about checking. When you do a timber frame wall, all your junctions of timber must be checked into the other piece of wood. So this is the timber framing that shows you the noggings, the studs, bracing, the lintels, ceiling joists, ceiling hangers, the floor joists, floor bearers, and so forth and so forth. Then the important one, very, very important aspect in creating stability is you must have bracings. Without bracing, your wall will collapse, and that's very important. Now, to provide comfort in the tropic is to keep the sun out and to have a lot of opening for wind to come through. Now, in keeping the sun out, you have large roofs, and that also keeps the rain out. But then you need the walls so that when it rains, you don't get wet. But then when it stops raining, it gets hot, and you don't want the walls. So how do you overcome it? So there are lots of things we have to look at in terms of overhanging eaves, sun shading, having lots of ventilation through floor, slats, timber seats, soffits, walls at low level, high level. You have high ceilings to induce convection air movement and cross ventilation, placements of walls and openings in strategic position to induce air movement, the venturi movement of air and so forth. But the most important thing is to keep the sun up, keep the walls cool. When the walls do not get sunlight, the interior do not get any heat. The reason why we use timber is because timber is a good material. It absorbs heat and it also loses heat very fast. So you don't have to worry about timber being hot in the evening. And here is a diagram to show the cross ventilation that goes through a building. And here is another cross ventilation study of how low opening, high opening, and rooftop shading to provide coolness. And these are just examples of how the walls are treated in the Salinger's house. You see, on top of the windows, we have all these vents, therefore hot air to escape. And also where the where the rafters are sitting on the wall plate, there are gaps in between. These gaps are very important because it allows cool air from the outside to come in, and they push the hot air that's formed underneath the roof tiles away. And that same thing here, you see. So these are the sort of things, the more apertures you can have in your building, the cooler your building will become. Look at all this, look at all this opening. And these are slats, timber slats that is used all the time. Does it maximize your shading? Look at it, it's all shaded in shadows. Look at underneath the shadows, and the seats are all slatted so that hot air may not build up and allows cool air to go through. Here you see in detail all the slots and so forth. And providing slats like this and slots, it allows water to drain off very fast. Now here again, you see large overhanging eaves. Yeah, very, very hard, very hard, so that your building gets shaded. See, we do this all the time for our designs. Our buildings always have huge overhanging eaves. Oh, what happened? So there you are. There are lots of shaded spaces and what have you underneath the building and so on. And where the lighted area are, that's where it gets hot. So you get the hot and the cool, and that helps ventilation. Now, the other very important thing, we have talked about construction. Next thing is your structural system. You see, a building must have a proper structural system. It's just that a person has a skeletal frame. So in this case, the structural system is the triangulated grid system. The triangular grid came about because of the client's requirements. In the last week's lecture, I explained the concept how the two triangles came about. So we use the triangle as a base for deriving the grid system. And a triangulated frame is always very stable. However, it may be a little bit difficult for some builders to build. So here you are, the floor plans. You can see how the triangulation works, and everything fits in to the grid pattern. And it's very important. So your design has a structure. You just cannot have a design that does not have a structure. Okay? Now, in timber construction, the next most important thing is the framing. The different systems of the post and beam framing. You got the timber frame walls. You have the roof framing, floor framing. The word framing is to describe putting together of different components. You frame them, and that's what it is. It's unlike steel or concrete. They become an integrated structure. The steel can be integrated as a portal. Concrete is mass concrete, whilst in timber, it has to be connected, hence framing. Look at the framing for the underside of the gazebo. You see, these are the main hip rafters of the roof, triangular shape, and these are the rafters that comes in. See, the way they are laid, they are neatly laid so that the whole thing looks pretty. It looks like it's part of a leaf. And this is the triangulation of the structure underneath the building. See, every column picks up a corner of the triangle. All right? And there it goes. So it's one triangle, two triangle, three triangle, and so forth and so forth. So everything fits into a pattern. Right? And because it has a pattern, then this junction was created using the traditional craftsmen of jointing, using dovetail locking device. And by providing this type of detailing, what happened here? It allows dismantling because everything is locked into place like Meccano said. See, that's a framing of a roof. This is a full-scale real-life model they make at the site. They test everything. They test, make sure that this connection works. and all these other works, and then the bird's mouth here works. Then after they know that it works, they produce a real thing and they put it up. Now, timber is a fascinating material. We have them in our forests, lots of them. And you can work with it easily. It's a dry material, it's easy to handle, and you can use very simple tools. So in those days, timber, the type of timber we used was very inexpensive and was, I think, something like about 150 to 180 ringgit a ton. Now that's very good. So, and the marvelous thing in terms of environmental friendliness and energy conservation, it's almost zero carbon footprint for timber to be produced. It's important that when we do something like this project, the carpenter, which in this case, Adam, he went into the forest to look for trees to cut himself. And he only selected trees that are not too big so that there's no wastage. And that's very important. Now, this is what timber framing is all about. You look at how much wood that's involved. Everything is framed. Look at this is all framed. But then they have to be braced. You see the cross bracing member here? Things like that. So you must know your construction. You must know your structure. You cannot not want to know about it. Now, the trees were all ecologically harvested, as I explained. He personally selected them. He cut them. They are from the forest near where he lived in Kelantan, near the Siamese border. And these trees were all cut, dressed, transported down to the site in KL, and then left there to be air dried. Now, none of our wood were kiln dry. Kiln drying wood for the tropic is wasteful because the average working moisture content of wood in our place is about 20%. Now, when you kiln dry timber, the kiln brings the moisture content down to around 8% because all these machines were designed for the temperate climate, and they do only temperate wood, soft wood, and their moisture content 8%. So you kiln dry in the tropics at 8%. The moment it comes out of the kiln, within 24 hours, the 8% moisture content has risen up to 20%. So it's an exercise in futility. So what we did in this project is it was left to air dry under a shaded place. That's the best way. The other element is how do you roof your building? Clay tiles, traditional clay tiles, they're handmade, they are sun-dried and not fired to the extent of bricks and other vitrified material. So again, the clay is easily available and they're all made and used and it serves a function. You see, we need tiles that will absorb a certain amount of moisture content because when the tile has a certain amount of moisture content in it, it also acts as a repellent for rainwater. Now, these tiles were custom made for the Salingers, and it had the name in Arabic underneath somewhere. This is a close view of the type of roofing. This is another close view of it. And this is the view of the underside. See, these tiles were all laid on these patterns. So the tile is slided in this way with a little bend at the end of the tile so that it hooks onto here. Now it's very clever because if you have to replace a tile which has broken, all you need to do is remove the broken tile, you pull it out, and then you slide in a new piece. So you see, the replacement is a very easy thing. So if this is not sustainable, ecologically friendly, and energy conservation, what is it? So all these were the sort of things that we had introduced into the Salinger's house. Another view of the underside of the roof, no insulation, because in the tropics you do not need insulation, because when you put on your your insulation, those wool, whatever you call them, fiberglass wool, it's like saying that in the tropics, to stay cool, you should put on a fur coat. I don't understand. See, when you leave the underside of your roof the way it is here, see, the heat would build up. But then because your roof is on an apex, whatever heat that builds up, it starts to travel up to the top. So there's always this movement. And if you have openings at the bottom and you allow cool air to come in, so it's pushing the hot air. And there's no chance for the hot air to build up. Now, most important is understanding how the traditional construction method works. Now, we were very fortunate in that we got this carpenter who was really quite a remarkable person because he understood how timber has to be used. We understood how it had to be used. We wanted to be done the proper way. Then we had an engineer who did not understand, and he said all the joints had to be done with metal gusset plates. But then when we met this contractor, Pak Adam, he said, no, we don't need to use steel. They will use the traditional method of cutting and so forth, because in that way it allows the building to be, dismantled. Now, this picture that you see here is the Salinger's house taken down and re-erected at a new site. Now, the fact that you've got this building looking exactly the way it was designed and built at the old place and relocated about 100 kilometers away is quite an amazing feat. So, this is what I call the test of the pudding is in its eating. This is another view of the restored and rebuilt Salinger's house. Everything is there the way it was designed. Now, this Park Adam is a remarkable person. He's been doing a lot of timber houses, traditional houses. So when he was shown the picture of the plan, the triangular plan, the friend who showed it to him said, hey, this is not the usual Malay house. So what are you going to do? He looked at it. After a while, he said, well, if they can draw it, I can build it. Now, that's gumption for you. He's a never say die guy, and I like that attitude. That's the thing, he's unfazed by challenges, the spirit of determination. He's cool. That's all. He's cool. Despite his handicap, he did not have a right hand. He was blown off in a fishing accident, and he's got a blind left eye. It never stopped him from working. And for him to get to this point and build this house, to have won the Aga Khan Award, for him to be brought all the way from Kelantan down to Kuala Lumpur. We flew out of the new Kuala Lumpur airport in 1998 when it was newly opened. All the way, we flew to Heathrow, then we went down to Madrid, and from Madrid we flew to Granada, and at Granada, at the Alhambra Palace, he received this award from the Aga Khan and the King of Spain. I think it's really a dream come true. And from the prize money, that his part of the prize money which he got, I was told he came back with that money. He bought a little gold pendant and gave it to all his grandchildren. So every one of them got a little thing to remember his grandfather, this great man's achievement. Wonderful. Now, when Pak Adam provided the alternative method of jointing the wood, we jumped at it. So he was able to do all this because it allowed for dismantling. And this guy, he is a carpenter, he's a rice planter, and he's also a farmer. So he has a cyclic life of 3 different activities. And I think he juggles it so that he doesn't work like what we do, 9 to 5 on one job. His one day could be over 3 jobs. This is not unlike some of the Indian farmers I met many years ago when I went to Kolhapur. They have this little 1 acre plot of land. He's a farmer because he plants a lot of vegetables, fruits, and what have you. Then he has a cow. So when he gets up in the morning, he works as a farmer. He tends his farm. Then he gets all the produce of vegetables, of fruits, or whatever it is. He takes it down to the market in Kolhapur. He sells it. Then at about 10 o'clock, he finishes in the market. He goes across the road and he works at the place as a part-time carpenter, right? That's this guy. He makes little tools for cooking and things like that, right? And he does that until about 3 o'clock. He goes home for lunch, and at 4 o'clock he takes his barber. He's a barber. He takes his barber kit, goes around the village to cut people's hair. So you see, he's got 3 jobs. Isn't it amazing? 3 jobs, and he's not bored. He's interested. Because after he's cutting hair, he gets home about 7 o'clock. He starts to look after his farm and he does his thing and what have you. A whole day. Now, this is something which we need to relook at our quality of life. Do we really need to have 1 job from 9 to 7, 9 to 5? There's something to think about. So, this project took 6 years to be constructed. But every year, he only worked 4 months at the site because the rest of the time of the year, he has to be back in his farm, growing his rice, harvesting his rice, plowing the field, and so forth, and also to look after his farm. So you see, he is the same as what the Indian farmer I saw in Kolhapur. So this guy is amazing. So if he spent 4 months in a year and it took him 6 years to build, that translated as he's only spent 24 months building this project. That's equivalent to 2 years. So it's not that long, a period of time. So these are some of the essence of what energy conservation, energy utilization, and so forth. We know how to spread out our efforts and time control, right? So I think it is wonderful. Now, having done this project and seen how it was done at close quarters, I think if we have more people like the carpenter Park Adam, I think similar techniques may be used for the construction of a lot of the buildings. And the tools they use, very simple. I managed to get a couple of pictures of what the traditional hand saw looked like. Very simple. Then they have this wood planers, hammers, drills, for drilling holes and whatever it is, plumber, all sorts of things. Chisels, axes, as for cutting wood and shaping big wood. It's all there. Simple, straight hand tools. You look at this guy, his man. He's using chisel. He's got a chisel here, right? But then he's using the side of an axe as a hammer. So he doesn't really use a hammer per se, but he uses the side of the axe. So these are some of the joints that they craft up. They make it look so effortless. But the chisel, the chiseling and so forth. So they are able to create a lot of joints. There's a column. So these are all the dovetail corners that sits into the column and so forth. It slide in and it's dropped in. And by the process of dropping the beams in, and then you fill the top with a wedge, it locks the whole, all the beams into the column, and it doesn't move anymore. So all these dovetail slots are for the dovetail to go in, and then you stick your wedges up here. And this cross member is for a beam to go right through. And here you are, this and so this is like where the wedge would go. So this is a picture of the drawing of the house, and you can see how the rhythm of the column are shown here in a very century-like manner. Then the rest of the walls are framed with noggings with studs that are at 24-inch centers. So you see the same rhythm throughout the whole building. Here is a section which illustrates how the framing works. The framing for the roof, the framing for the roof, so there, the framing for the floor, the framing for the walls, the framing for the seats and so forth. It's all there. So every one of these frame, the junction, every one of the junction has to be worked out. There's no two ways about it. And here's another section of the same building and the amount of so this is my second last slide. I just want to show you this site on the right was a house that we designed back in 2016, 22 years, 22 years after the Salinger's house. Interestingly, the client was also a couple, and their brief were almost identical as the Salinger's house. But then we could not produce another Salinger's house on this site. So it was quite a challenge for us to come up with this design. And this is what the plan looked like in the end. You see the plan is triangulated, three-sided, three-pointed star, whilst the Salinger's house was two triangles over each other. But the roof plan of the Tan's house is like this. So you can see a slight difference, okay? And but the structural system are almost the same, triangulated. Uh, here is all the wooden triangulation. Here is a steel triangulation. Uh, for this house, we use steel and concrete instead of timber because we wanted to explore uh, ideas and to see how we could bring it forward to a greater plane, you know. Now, let me just go back and show you what this house was. You saw it earlier, but you probably forgot. Let me revert my slides. Yeah, this is a house. So this is, as a matter of curiosity, you know, it's triangular. It's got lots of similarity. At least there's a lot of similar DNA in the selection of the material and in the selection of the structural system for this place because the requirements are almost identical. So with that, I end my presentation today. I hope it's been of help to you. Oh, what happened to mine? So, okay. So thank you very much. Sorry
Thank you.
for the tropical rainstorm that interrupted our whole thing.
No problem, sir. It happens. Yeah. Thank you, sir, for yet another extremely important, informative session. We have a couple of questions coming in. We'll take that quickly. The first question being, how was the fireproofing done in, because since the building was extensively made of wood, any fireproofing that was done to the timber before use?
That's interesting. Timber is a very good fire resistant material. A 1/4 inch of wood would take about 15 minutes to burn. So if you have 1 inch of timber, it would take no less than 1 hour. And also, when timber burns, it starts to char on the outside. And when it chars, it prevents oxygen from getting in. And as we know, combustion is dependent on oxygen. So, lots of people think that timber is a fire risk. But let me tell you, timber is one of the best material. It's better than steel. Steel loses its strength at 1000 degrees. Timber does not lose its strength.
Thank you, sir. One more question, please. What are your thoughts on approach towards sustainability and energy conservation when it comes to a building or a site in an urban fabric?
Well, you apply the same principle, you apply the same yardstick. So it's a question of different different strokes for different blocks. So depending on the site, you still give the same sort of strokes, but then depending on the rhythm, you know. I mean, you can dance, you can do the cha-cha, you can do the rumba, you can do the jive. You are dancing, but then it's to a different rhythm, different beat, or salsa.
Thank you, sir. Before concluding the session, may I please invite our guest of honor, Architect Alok Ranjan, sir, to say a few words, please. Architect Alok Ranjan.
Hello.
Yeah.
Hi.
Very good presentation by Jimmy Lim, and we have learned a lot. at this stage also we have learned a lot. Now sustainable architecture is a demand of the day. Now whatever we are seeing is in India also we are going for the IGPC norms and other things. So you have tell very good thing that location and then the existing tree should not be cut. Then sustainable construction technology, all of things are there. And in my opinion, every institute should have this type of lecture of yours so that the students should be benefited. Very good approach, sir. And I'm very overwhelmed to learn about something of the timber. So thank you very much. And on behalf of the whole fraternity of architects, we thank you for giving such a good presentation and preserving the tea and the sustainable construction material. You have used construction material, and more or less that is very important that you have honored the carpenter and the local craftsmen. That is a very good thing. Actually, what happened in the everywhere is people are forgetting about the craftsmen and the local person, those who are actually implementing the things. We as an architect, we are designing the things, but implementation process is run by the workers. So if we are acknowledging the workers, it's a very good. So thank you very much. I am thankful to Aditya College also for giving me the opportunity to say something. Thanks a lot. Thanks, Neha.
Thank you. Can't hear you.
May I please invite Dr. Ganesh Babu sir now to extend his thanks to the guests.
Yeah, thank you, Neha. Because indeed it was an excellent, informative presentation, Dr. Jimmy. We are overwhelmed with your information and the way you have expressed it down to earth to students for them to perceive it. And in fact, from last week, we had a lot of inquiries that we can have you on a few more sessions, as I had also messaged you. And we will always work on this and we'll see your comfort levels. I also thank Alok Ranjan sir for readily accepting to be with us and sharing his views and encouraging us. It is not that today he is here, as I mentioned, right from day one, he has been inspiring us and guiding us all the way. He is the mentor of Triple-AD.
Thank you, sir. Thank you.
I would like to make it specific and clear. Yes. Thank you, sir, for joining us. I would also like to acknowledge the presence of architect Amon sir, who was very enthusiastic. In fact, we had an opportunity to welcome him for one of the functions a couple of months back, but due to his schedule, we couldn't. Today, he is with us on board. Amok sir, I would like to welcome you and share a few words before we conclude the formal session.
Hello.
Hello. Yes, sir. Welcome, sir.
Thank you for giving me chance to hear Professor Jim. And Alokji has just, in his very short but very sweet words, he has explained the necessity of the sustainability with local materials and craft. It is our, in India, we are just going for technology not based on crafts. One thing is there, in India nowadays, wood has been prohibited. So detailing of these type of joints may not help us, but the idea of using the material and the craft in any way is to be there in every architect's mind, so that he can use judiciously the local crafts and local material as we have been taught to, but not has been reflected in practice. I wish you all best. I'll just watch your another webinars also. Thank you.
Thank you, sir, for joining us and sharing a few words. I would once again like to thank all the delegates present here today, and I wish all of you will support us by joining us every week on Thursdays and Fridays. Except today being an exception, all our sessions will happen between 5 and 6 in the evening. So please do get connected and encourage us. Thank you, sir. And over to Neha.
Thank you, sir. We have come to the end of the session. It's my privilege and honor to give a vote of thanks for today's event. First and foremost, a big thank you to Dr. Jimilim for an exemplary session on Salinger House. The way you explained the nuances both in design and construction process has huge educational value. And as you said, designing contemporary buildings which are sensitive to the cultural context and the climate is what is required rather than going after a rating system. I also thank our guest of honor, Architect Alok Ranjan sir, for joining us today. Your presence would always motivate us, sir. It is imperative that I acknowledge our team without whom these sessions wouldn't have been possible. Thank you, Architect Senthil, our webinar coordinator, and Architect Harshita, our broadcast coordinator. Let me take this opportunity to also thank our principal, Dr. Ganesh Babu, sir, for initiating and coordinating this webinar incubation series. I also thank the management of Aditya Group of Institutions for extending their support always. Not the least, I thank all the delegates and esteemed member of the architectural fraternity who joined us today. As sir said, thank you for joining us, and we hope for a continued association for all the upcoming webinars that we have planned ahead. With this, we conclude today's session, and we request everybody to join us again tomorrow at 5 p.m. for yet another webinar. Thank you, everybody. Thank you, sir. Thank you.